All right. So let's see. Hopefully you've seen the library series Linear 1 and Linear 2, where I talk about the problems that I'm about to do on the board. Mostly going to be just mechanical here, just for reps, practice. Problem number six, however, I'll have a little insight on that I was surprised to think about, but that's why I love reps. I can't tell you how many I've done over the years, but just thought about something else with problem number 6. So you might want to check that one out from a conceptual standpoint when we get there. And let's have at it, get the mechanics down. And the mechanics of this linear function is going to be a template for the quadratic, the cubic, exponential, logarithm, sinusoid, all of them. Right. So I'm going to put a to the first power because it's really operational change in the denominator here that we're going to be talking about in other situations. Okay, so I'll just put equals y over here. All right, so I want to get a number 9 out when I put a -2 in. If I add 2 to -2, it's 0, which means that I can assign the y value because it doesn't matter what I multiply 0 by, this term is going to disappear. So then instead of doing y2 minus y1, don't do that. And don't do x2 minus x1. Ask yourself, how do you get from -2 to 5? Well, you go up 7. Okay, so the secret here is to get multiples of 7 for user-friendly numbers. All right, and how do you get from 9 to 1? -8. Okay, so there's your answer. Generally speaking, y equals on the left side, but actually I think it reads better from left to right. It's a little dyslexic, right to left. I don't know if I want to use that term. Just the brain doesn't orient itself as easily. Okay, so let's plug in 5 and let's see if we get a y value of 1 to avoid any carelessness. Okay, and I'm hoping that, 2 or 3 weeks from now, you do this in 10 seconds or less. It's taking longer because I'm talking to you. 7's cancel, -8 plus 9 is 1. Let's move on to the next problem. All right, problem number 2. Yeah, so many textbooks teach y equals mx plus b because people understand it. Okay, and that is a product. And so what do we plug in for x? 0. And that gets us our y-intercept. Okay, great. I'm going to be working with y equals ax minus h plus k to the first because that's going to change to the second, the third, the fourth, the fifth. And then, of course, it gets a little more complicated after quadratics. Okay, but let's just look at this now and do the mechanics. So it doesn't matter what number I plug in here. I'm going to multiply it times -3 fifths. Okay, so there's the distribution. There's -6 fifths. I need to add fifths. All right, in order to put these fractions together, they both have to be common denominator. And so 5 times 9 is 45. And lo and behold, we have -3 fifths x plus take 6 from 45, 39 fifths. All right, so what way do we want to check this? Let's graph it. All right, let's just graph it real quick, real small, simple sketch. -2, 9. -2 9's up here. I'm going down a 3 to 5 ratio. That looks about a 3 to 5 ratio. This says I'm starting at 39 fifths, which is a little less than 8 right here. And I'm going down at a 3 to 5 ratio. Well, but they look the same. Let's move on. All right, let's see if we can name some coordinates, a whole bunch of coordinates, data. Well, I know if I'm dividing by 3, it sure would be nice if that was a 0, if that was a 3, if that was a 6, if that was a 9, if that was a 12. I think those divisions are pretty easy. So we got to start with a 7. 7 minus 7 equals 0, and these jump by 3. I think I'll jump by 3. All right, I did a bunch of them. All right, let's move this -4 to the other side, get that left to right. So it's addition of 4 on the other side. And so if I put in a 7, this term becomes 0, and I get that 4. And then I guess if that's the change in x, that's the change in y, 5. So I'm going to go 9, 14, 19, That's good enough. 16 gets you 19. Let's see if it's true. 16 minus 7 is 9. Oh, I like that. That's one of our multiples of 3. 3 goes into 9 3 times. Oh, yeah. 3 times 5, 15 plus 4, 19. I've checked my work. Let's move on. All right, linear equation. Addition of 7. Remember in my class, I do not want to see minus 7 minus 7. I don't want to see it. I want you to get some practice doing computations, addition of 7, subtraction of 7, inverse operations is going to be stressed in this class. And I don't think, please pardon my dear Aunt Sally, talks about the inverse of sinusoids or logarithms or exponentials, whatever. So subtract 7 minus 30. Division by 5 becomes multiplication by 5. Multiplication by -3 becomes division by -3. Let's see if 50 works. Oh, 50 is nice. Nice round number that 5 goes into. 10 times. 10 times -3, -30, plus 7. Oh yeah, -23. Let's move on. Here's problem number 6. So I don't know, I was just in the gym and I was thinking about this problem for some reason. I don't know why, but I was like, what about 2x minus 6y? Let's actually start with what I thought of over there. 2x minus 3y equals 0. Come back to that in a minute. Well, if this goes up by 1, and this reminded me of an implicit differentiation problem, 3, 4, 5 triangle. There's a video, right? There's a video about implicit differentiation that works with this, and looking at this getting bigger in order to maintain the constant of 25, that had to get smaller, and there was a ratio of change there. And then I thought to myself, well, that same ratio of change is taking place in this problem. And this comes evolution-wise a lot earlier than calculus. All right, so let's let x equal 1. If x equals 1, this has gone up by 2, which means that this term has to go down by 2 to maintain that constant. Okay, so, phew. So -3 times what value? Okay, I did this downstairs. I want to make sure I get this right. Times what value gets us -2? I guess whatever that value is, we'll use v, is going to be 2/3. 2/3 of that x value is what's required to maintain this constant. All right, so 2x minus 3y equals 0. I don't like dividing by a negative, but I'm gonna write here minus 2x and y equals 2/3 of that x value. Yeah, so 2 times 1 plus, or it was minus, wasn't it? Yes, minus 2/3 times y value equaling 0. Yeah. And I guess we got to get rid of the 3 here, huh? Yeah, that's 2/3 of that x value. Yeah. All right. So somewhere in there, I might not have said exactly what I wanted to, but maybe it planted a seed. All right. So how do we graph this? Well, these are products. 2 times x is a product, and we always want to set products to 0. We learned something. Minus 6 times y is a product. We want to set that product to 0. We learned something. So let's let x equals 0 first. Well, that's like covering it up. Minus 6y equals 24, y is -4. So 0 gets me -4. And I know the subtraction means that if this one gets bigger, I have to get this one to be bigger as well. But there's that ratio of change that has to occur in order to equal a constant K-O-N-S-T-A-N-T. That's how you spell constant. My grandson thinks you spell cat, C-A-T, and we all know cat, K-A-T, cat, right? He keeps arguing with me, I don't know why. What kind of education he's getting in that school is. All right, so let's cover up the 2x this time. Oh no, I solved for y already. Let's cover up the y this time. We can see x equals 12. And so if you want any credit for a problem like this on the test I'm going to give you, you better mimic this conversation, because if you start solving this for that and trying to get it into mx plus b form, I'm not giving you any credit. This is a graphing form. It means you don't have to touch it. You just write what you see. All right, maybe I could have said that a little nicer. Excuse me. All right, so parallels and perpendiculars. All right, in the linear 1 and 2, we talk about and draw out the parallels and the perpendiculars. Here, we're just gonna look at, you don't care about that number. If you see that number change, you let me know. All right, I'll give you my number maybe in the comment section. All right, but if you see that number change at all, keep looking at it. If you're seeing it changing, please get some help. All right, so 3x equals 8y. I don't like dividing by negatives, so 3/8 is the ratio of change in this problem. I like that term, ratio of change. All right, so parallel, let's get it through about 4/7. All right, so parallel, Parker, it's my grandson, Parker. So let's go y equals same slope for parallel. And through 4/7 is x minus 4 plus 7. All right, so that gets that job done. Perpendicular. Perpendicular is the negative reciprocal. Negative 8/3, x minus 4 plus 7. Okay, this is just for practice. That was explained somewhere else so that these can be done quickly. I hope. I probably didn't say it at the start. I should have. Pause the video. You're practicing these, right? Try them on your own. Then we do them together. All right, so we could do substitution or elimination. We got one linear function. Subtraction means that one's going up. Addition means this one's coming down. We're trying to find that x and that y. All right, so let's look at elimination is easier than substitution in most problems like this. So let's get this one to be minus 4x so that the 4x column cancels. So let's multiply this by -2, which gets us minus 4x plus 10y equals -2, making sure, so easy to make mistakes with these. Then you got 4x plus 7y equals 19. Feel free to take shortcuts as you develop your ability and skill with these problems. That's going to cancel. I didn't need to write that part. It's going to cancel. Could have gone right to here. All right, so that's 17y equals 17. I like addition rather than subtracting a negative. Students make more errors. Y equals 1. If y equals 1, then 4x plus 7 equals 19. We can see x equals 3. Okay, and we can check it up here, 3 and 1, 6 minus 5 is 1. So we've already checked it, that works. But let's find x equals 3 by canceling the y's because you don't always get to do just one multiplication with these. What am I trying to say here? These transformations. So let's multiply this and this by whatever gets rid of this column so we can solve for the x's. We want to see x equal 3 show up. So if I multiply that by 7, this becomes minus 35. And if I multiply this one by 5, that becomes positive 35. So let's do that. So there's your 14x. Can I take the shortcut? I won't. Minus 35y, because you're just learning this, equals 7. I had to be careful. 3 opportunities for a careless mistake. Another 3 opportunities. I make more mistakes on this problem than any other in math. Drives me nuts. We add these up, that column goes, we get 34x equals 102. Yeah, if I multiply x by 34 by 3, I get 102. And we already checked 3, 1 worked. So we're done. There's your practice. 9 problems. That's your first 9 problem practice. And I'm going to make a whole bunch of different videos. Practice as many times as you want. And every now and then, when you get to the point where you can do them easily, hey, just do it every two weeks. You know, but you got to keep it fresh. You got to keep it so that you have it with you and it's not memorized for a test. Working knowledge is different than test knowledge. Oh boy, do we know that. Okay, see you in class.